Good afternoon. My name is Austin Harris, and I'm here with Jonathan Kuhn to give a presentation on using Eagle by Autodesk for our MECH 6970 Applied Mechatronics class.
Yeah, so let's get going. So if you're going to be doing Eagle, you got to download it. So you can go to Autodesk website. It's free for students. The free version is pretty complete. It only allows you to do 2-layer boards, which most things will be doing is 2 layers. So there's a link. Download it. So what is Eagle? It's a CAD software, so you can turn your breadboard circuits into printed PCB boards. The pictures below are like the first project I ever did. It really wasn't too hard. I'd never done it before. I just watched some tutorials, made a functioning circuit. It went into a 40 millimeter projectile. It's a fuse that turns on electronic payloads. Eagle's really easy to use. It has a really big open source community, a lot of resources out there, people helping you figure out how to work things.
So when you first want to start a project in Eagle, you first open it and that'll open to the control panel. And from there you are going to you're going to start with your schematic and go into a board file. And so these two files work together and are hubbed at the control panel for the whole time while you're doing the project. So like I said, first you're going to begin with the schematic. So the first thing, kind of an overview of the schematic process is you're going to find and place all of the components for your board on into the schematic. And you're going to connect the components for your circuit and then check out all of it by running an electrical rule check or ERC. So the first part is to add in components to your schematic. So these parts are located in libraries, and each part has a schematic symbol and a printed circuit board footprint for when you're doing your design later. This schematic symbols are just there to kind of help you visualize the electrical connections and help you make sense of the circuit you're building, while the footprint actually is the shape in reality of your component. So libraries are controlled in the control panel, and there's a lot of libraries that aren't necessarily downloaded into your Eagle program that you have to go download from the internet and add them into your control panel. A lot of those libraries are found on GitHub, and honestly, the hardest part of this whole process is getting the parts from the different libraries into Eagle correctly. And so when you're using a library, you want to make sure that the libraries that have the components that you want to use have use checked before you try to add them into your schematic. Just as you download them from GitHub, you want to make sure that you get the whole zip file. You want to try and find comprehensive files from manufacturers just to make it easy on yourself as you're adding the components. If a part that you want cannot be found in Eagle, like I said, you can download it from the internet. And once you get it into the control panel, you want to go ahead and click Use, like I mentioned earlier, as shown in this picture here below. So after you get all of your parts placed into your schematic, you want to orient them in a way that helps you to understand the flow of your circuit. And so if you look over here on the right-hand side, there's a picture that shows all the different ways to move and orient your parts. So to use any of those, you need to first click on that, and then on the component that you want to move or rotate, you click on the red cross, as you can see in the component down at the bottom of the screen. So that's where you're going to select the component that you want to move around. And if you want to move several components at once, it's helpful to group them together. And so if you right click in the center of a group and initiate the tool, you're able to move several components all at once. So once you get all of your components placed where you want them, next you need to connect the components using nets. And so it's pretty much, a net is like a wire or a trace on an actual circuit board. And so it just represents electrical connection between the two components. If you are connecting several items to one net, it's important that you realize the difference between a junction and an overlap. So a junction is shown at the bottom, and it's represented by a green circle at your net, whereas an overlap is just where the nets are crossing but not connected. And so you can see that on the right-hand side with the arrow pointing to the overlap. Those nets are not connected. One thing just to quickly mention is that each part can be named and had values added to it. And this kind of helps you keep track of what part is what and the value and what it contributes to the circuit. And it just helps you confirm your circuit design in general. You can also edit the text by clicking on the tool and clicking the gray cross. So once your schematic is complete, the final step that you want to do is do an electrical rule or ERC check. And so this is to help you catch any errors before you move on to your PCB design. So it's important to note the difference. There's errors and there are warnings. Warnings are kind of like a yellow caution. There are definitely things that you want to check out, but may not be anything too problematic. But an error is for sure something that needs to be resolved before you move on to your PCB. So you just want to make sure that any errors or warnings that are given to you, you go through and approve to make sure that they are all right.
Yeah, so the next part of your project will be to actually populate your board. So like Austin said, the schematic kind of gives you a general overview of all the electrical connections that need to be made, and it works synchronously with your board file. So here I kind of have an example of a snapshot of one of my boards. It shows, we'll kind of go over the different components. Number one, there's a trace. That's your wire, your electrical connection between points. You have what's called a via. That's number two. That's a through hole that has electrical connections. So it connects one side of the board to the other. So it would be the top to the bottom. Then you have number three. That's a component through hole. That's just a hole through the board. And typically those come kind of pre-configured on a part. And those that kind of also act like vias. There's that electrical connection from the top to the bottom layer. And then number four is an air wire. So an air wire is how the schematic talks to the board files. So that air wire means that you need to make a trace between 2 points on your board. It doesn't tell you how you need to do it. It's just showing you that you need to make one. And so that's a really good tool because it keeps you from missing components. It gets really messy when you have all these traces. And then of course 5 and 6, those are your component names and values that Austin mentioned you can add. And it just helps you keep track of what part is what. All right, so how do you make a board? So you're on your schematic, upper right picture, there's a button called generate/switch to board. You click that and it automatically makes a board file. And the first thing you're going to do is you're going to have to make your actual board, like what are the dimensions of your board. And so you do that in what's called the dimension layer. It's 2-0 dimension. So make sure you're in that layer, and then you can move or add a shape, and that'll be the perimeter of your board file. And you see to the bottom left in that big picture at the bottom, it's showing all my components, and they haven't been placed yet, so you're going to have to place them, but it kind of just sticks them in there, and then you can move them as you wish and orient them how you like. Okay, and then so the board layers. There are multiple layers in this program. The key ones are the top and the bottom layer. Those two layers are your copper traces. That's what you'll be using to connect your parts together. But there's all these other layers that you need to learn that control different things, and we'll kind of go over some of those, but really that's something you need to play around with and learn. And you can turn layers on and off as far as like being able to visually see them, and that'll help you kind of reduce the chaos as you're drawing stuff. So the next thing is drawing traces. So like I said, there'll be air wires between each connection, and then there's a really good tool. It's called the route air wire tool, and it basically just allows you to draw those electrical connections. One key note is it's bad practice to do right angles for your traces. This causes electrical interference and could potentially corrupt data. So again, it has a tool to help you with that, but just make sure you're cutting your corners, kind of as you see on the bottom right corner. Yeah. So the ground plane. It's pretty common practice when you're drawing your ground traces. So like ground is like the negative of the battery, and a lot of times your circuitry has a ground also. It's common practice to pour a copper layer for your ground circuit instead of just drawing individual wires. You use that using the polygon tool and rat's nest. Again, I would suggest looking up a tutorial on this, but ultimately this helps. It makes it easier for the board house to produce, and it also reduces electrical interference. It kind of creates a Faraday cage. All right, and then your silk screen. A silk screen is a printed layer on your PCB. So if you see all the gray writing on that PCB down there, that's your silk screen. It's not a layer. It's just a print, just to help the user know what's what. And you can edit that layer. You can add to it. You can subtract. You can move stuff around, and it just makes your board look more professional. But also, it helps you populate the board. And those are controlled in the layers. The T place. So place would be kind of like the outline of the part. T names, B names. That's the name of the actual part. Then values. And the T and B just stands for top and bottom. So again, you got a two-sided board. So there's stuff on the top and stuff on the bottom of your board. All right, the solder mask or stop. So when they make the board, they put this polymer layer on top that helps with soldering. And there is a layer, T-stop and B-stop, that actually tells the board house to not put that layer there. And they do that for all your pads, for your vias, and other things. So if you have a spot on your board where you either want or don't want that stop, you need to correct that layer and make that change. So that's how you do that. Of course, all right, so you populate your board, you've done your traces, you've edited all your layers. You're going to do what's called a DRC check, and it does a lot of things, but the main thing to note is that it checks your clearances, make sure things aren't too close that the board house cannot produce that accurately. So just mess around with that. A lot of the default settings are accurate or are good enough. So just make sure you use the DRC check before you finish. All right, once you have finished, you're happy with your board, you're ready to send it to the board house to get produced. And so most board houses use what's called a Gerber file. You can download, it's called a Gerber file, and then you're going to have to use what's called the CAM processor, and it basically just converts all your layers into different Gerber files. And the board house reads each layer to know where to draw the copper, where to do the silk screen, where to do your stop mask, etc. So, and you can actually view those files and kind of see what they look like before it's sent. But most of the time it works. You just process the job, save it to a zip folder, and then you can send it straight to the board house. There's a lot of different ones. JLCPCB.com is really good. I just threw this up there real quick, and it was $2 for one board before shipping. But I mean, it's pretty incredible how cheap and easy it is to get these quotes. And they got 3-day shipping or something like that. So, oh yeah, and then also if if the part you're looking for it does not exist or you can't find it or it's something custom, you can create a custom part for your schematic and board file. It's pretty hard to do. Well, it's not that hard, but it would take too long for this tutorial. So look it up on the internet. At this point, you should be pretty capable to figure that on your own. And then, of course, there's some basic tutorials out there. We walked through Autodesk's tutorial. So if you want to check out that video, there's a link right there. But yeah, good luck. I hope this gave you a good intro and hope to get you started. A lot of it is Eagle's really good software and it's pretty intuitive a lot of times. So, but yeah, just look it up on the internet. There's a lot of resources out there. Yeah, good luck.